The first thing that I want to do is review if you're getting common denominators with just numbers. So if you have 7 over 22 plus 5 over 11, you could think of this. The whole point of today is trying to figure out what's missing from one of the denominators or both, and then multiply in the numerator and denominator to make the denominators the same. So this you could think of as 7 over 2 times 11. And then you can see that this denominator is missing a 2. So we could multiply in the top and bottom by 2. This is like backwards reducing. We're unreducing this. So it's still the same number. Technically, we're multiplying by 1 if we do it in the numerator and the denominator. If you wanted to think of it, 2 over 2 is just 1, so we're not really changing anything, we're just unreducing. And then we would have 7 over 22 plus 10 over 22. When the denominator is the same, that's just like yesterday, we can write the denominator once, and then combine the top. So that's what we're doing today. There's also an example that I'm going to have that looks like this. When there's absolutely nothing in common, then you'd have to change both of the denominators. I think the most common mistake is that people forget to multiply the top as well. So make sure you're doing the bottom and the top. If you don't, then you're not multiplying by, like 4 over 4 is 1. If you don't do it in the top, then you're just changing the problem and not actually unreducing. So on these, you'd have to, like, this one's missing a 4, this one's missing a 7, so you have to multiply on each of them. So we get 35 over 28 minus 12 over 28, and we can write the denominator once, and we get that. So we're going to be doing each of those things, but with rational expressions, with variables and numbers. First, we have to figure out how to make the denominators the same, and we're going to do that first by factoring the denominator. Then we can see what's missing. So here we could just tell that one was missing a 4, one was missing a 7. On this one, you could probably also just tell, but this one was missing a 2. We're going to write it like this. Something multiplied by something else. So factor denominator, if you can. So if we had x squared minus 25, since there's a minus in between, can you stop? This is in the video now.
Wait, you're making a video?
Yes.
Oh, my bad.
So
I can't wait to watch this later.
You're not going to watch it later.
He's right, though.
So x and 5, if this had a plus in between, we wouldn't be able to do this, but this is a difference of squares, so we can write x plus 5 and x minus 5. So I can write down 11 over x minus 5 minus 3 over x plus 5, x minus 5. So hopefully we can tell that this one's missing an x plus 5. So that's what I have to multiply in the top and bottom here. I don't have to do anything to this one. Then I can distribute. So I would get 11x plus 5 over x plus 5, x minus, oh, thank you.
wait a minute.
11x plus 55.
Oh, so I have to wait a second.
Yeah, I didn't distribute all the way. And then three stays the same. If there was more than one term, I would distribute the negative to everything, but there's only one term, so the negative will go to the 3, and then I can combine like terms in the top. The 3 and the 55 will combine, so I get 11x plus 52 over x plus 5, x minus 5. So the first step was to factor the denominator. The second step was to figure out what's missing. The third step was to multiply in the top and the bottom. Don't forget to do both, bottom and the top. Extra. Any questions on this? No? Minus 4. In this, we can put it over 1. And then this one's missing an x plus 6. So we would multiply in the top and the bottom, x plus 6. This 1 we would distribute. If it was a different number, we would distribute it, but it doesn't change anything. So I have 12 over x plus 6 minus, I'm going to distribute the 4, so 4x plus 24, x plus 6, and I'm going to make sure and distribute the minus there. That's another mistake that a lot of people miss. Don't forget to distribute. If it was a plus, we wouldn't need to do anything. We just combine the tops, but here I'm going to write 12 minus 4x minus 24. And the denominators are the same, so I can write it once. The 12 and then the minus 24 are like terms, so we can combine those. And then I can factor the top. So I'm going to try that and see if anything cancels out. In this case, nothing will cancel out, but I'd factor just to see. I can divide by negative 4. Negative 4 on the outside, x plus 3. So then my final answer could be negative 4 over or times x plus 3 all over x plus 6. If I got an x plus 6 on the inside, then I'd be able to cancel, but I don't. I don't cancel here because it's not exactly the same. If you wrote it as the first thing, if you wrote it like this, I would accept that as well. But you do want to factor if you can so that you can see if it cancels. I don't think any of the problems on this assignment cancel. So on this we have 3 over x minus 3 minus 5 over x plus 2. So here I'd put these in parentheses, x minus 3, x minus 3. Also later on, I'm going to do this in a separate step, but later on we're going to distribute this negative. Don't forget that as well. X plus 2. So I have 3x plus 6 over x plus 2 times x minus 3 minus 5x minus 15 over x plus 2, x minus 3. I'm going to distribute this negative now. So, and then the denominators are the same, so I can write it once. And then I have 3x plus 6 minus 5x plus 15. The negative 5x and the 3x are like terms. The 15 and the 6 are like terms. So then I can write down my answer, negative 2x, thank you, plus 21. I can't factor that. So that's my answer. If you wanted to, you can multiply out either using the box or FOIL. You can multiply this out, or you can leave it. I think I would just leave it.